Question 15 of this exercise says a vertical pole of length 6 meter casts a shadow 4 meter long on the ground, and at the same time a tower casts a shadow 28 meters long. Find the height of the tower. So to understand this question better, let's first draw a figure representing all the given information. Okay, so here's a figure that I've drawn for you. And let me explain this figure carefully, because basically this figure is the key to solving the problem. So follow me carefully as I explain how I've drawn this figure. So this here that you see, this thing is the vertical pole, and this is the shadow of the pole, and this is rays of sunlight falling and creating this shadow. And similarly we have this tower here, and this is the shadow of the tower, and these rays are the rays that are creating the shadow of the tower. Okay, so what the problem statement is telling us is that the height of the pole is 6 meters, and the shadow casted by the pole is 4 meters long. So this here is 4 meters, this shadow. Okay, and at the same time, this tower, whose height we don't know, is casting a shadow that is 28 meters long. So using these three numbers, 4 meters, 6 meters and 28 meters, we have to find what is the height of the tower. So here's the key idea involved. If the shadows are being measured at the same time, then the sun's elevation will be exactly the same for both the pole and the tower, assuming that they are nearby. They are in the same area. So in other words, the sun will be at the same elevation in the sky, whether you are near the pole or near the tower. And this means that the sun rays will form the same angle with the ground. So if you take this angle here, formed between sun rays and the ground, the slant of the sun rays, and if you take this angle here, these two angles will be the same if you are measuring the shadow at the same time. Now this leads to an interesting conclusion, and let me show you what that is. So consider the triangle that is formed by this point here, which is the top of the pole, this point here, which is the foot of the pole, and this point here, which is the tip of the pole's shadow. Okay, so let's call these 3 points A, B and C. So if you observe carefully, triangle ABC is a right angled triangle, and let me highlight this triangle for you. So triangle ABC, if you take this triangle, this is a right angled triangle, right? And similarly, if you consider the triangle that's formed by the top of the tower, which is this point here, the foot of the tower, which is this point here, and the tip of the tower's shadow, which is this point here, these 3 points also form a right angled triangle. So let's call these 3 points PQR. So PQR also forms a right angled triangle, and let me highlight that as well. So PQR, so this triangle is also a right angled triangle. And now it's easy to see that these two triangles must be similar. Why? Because this angle at A is equal to the angle at P, as because the shadow is being measured at the same time, and also the angle ABC is 90 because the pole is vertical, and similarly the tower is vertical, so angle PQR is also 90 degrees. So by AA similarity, the two triangles will be similar, and therefore the sides of the triangle will be proportional, and from there we can find the height of the tower. Okay, so let me write this reasoning now. So in triangle ABC and triangle PQR, these are the two triangles we are comparing. Angle A is equal to angle P, and this is because the elevation of the sun is the same, because the shadow is being measured at the same time. The shadows are being measured at the same time. And similarly, angle B is equal to angle Q. This is basically because the pole and the tower, both of them are vertical, 90 degrees. Okay, and because of this, we can say that triangle ABC must be similar to triangle PQR by the AA similarity criterion. Okay, and now because these two triangles are similar, their sides must be proportional. So therefore we can say that BC, which is the pole's height, observe the figure, BC is the pole's height, by the corresponding side in PQR is QR, the tower's height. This must be equal to AB, the pole's shadow, by PQ, the tower's shadow. Okay, so let's plug in the values. So BC is 6 meters, QR is unknown, AB is 4 meters, and PQ is 28 meters. So 4 meters by 28 meters is 1 by 7. So if we cross multiply now, we will get the value of QR. So QR will be 7 into 6 if we take it to the left side. So 7 into 6 or 42 meters. So the length of QR, or basically the height of the tower, is 42 meters. This is what we had to find. So this is the answer for question 15. So we were able to find the height of the tower just from the length of its shadow, which is 28 meters, and without measuring it directly. This technique has been a very common technique in measuring the heights of tall buildings and other structures. Just find the length of the building's shadow, in this case 28 meters, and at the same time take a short stick or rod whose length you know, like in this case the pole's length is 6 meters, and keeping it vertical, find its shadow's length as well, which was 4 meters in this case. And from these three lengths, from these three numbers, the length of the rod and the lengths of the two shadows, you can find the height of the building. So this is a very cool application of the concept of similarity. But remember, the shadows must be measured at exactly the same time. Otherwise, the sun's elevation will not be the same and the two triangles will not be similar. Okay, so that completes question number 15. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.